Service level objectives, or SLOs, are one of the fundamental principles of site reliability engineering. We use them to precisely quantify the reliability target we want to achieve in our service. But how do we measure them? And what do we do when our SLO monitoring tells us that there's a problem? With service monitoring, we can track our SLOs and error budgets and quickly respond when our service is having an issue. This is the Stack Doctor. First, let's review the basics. You may have heard of SLOs, but what's an SLI? Let's clearly define both of those. Our overall objective here is to accurately quantify reliability and measure our user happiness. The actual thing we'll use as a proxy for that is called the Service Level Indicator, or SLI. We need to define that indicator for our service. An easy place to start is by using one of our golden signals. We'll put the link to the monitoring chapter of the SRE book where those are explained in the notes below. You can also watch the excellent video created by Liz and Seth that explains this topic in greater detail. We'll link to that too. Generally, SLIs fall into two categories. Request-based SLIs measure the fraction of good units of work against the total. For example, what percentage of requests to an HTTP endpoint were successful in a given time window. Window-based SLIs measure the fraction of time intervals during which the service meets some threshold over a given time window. Let's use an example. If we have an App Engine service, we can use the response count metric as our SLI. Specifically, we can count our good responses by filtering that metric for only responses that return an HTTP 200, and use the unfiltered value to count our total responses. We divide the two to arrive at the fraction or ratio of good to total, and that's our SLI. Now let's talk about SLOs. A service level objective is the target value for our SLI measured over time. It's generally comprised of three things: the SLI, a target for the SLI, and a window over which it's measured called the compliance period. So for our simple HTTP service, we may set our SLO as 99% of requests return HTTP 200 for the last 28 days. Our error budget then is essentially the inverse of the SLO. In this example, we're expecting that 1% of our requests will fail every day. Now that we have that sorted out, let's take a look at how we can use the Service Monitoring API to create, track, and alert on our SLOs. First, we define our SLI and SLO using a JSON payload and send it to the API to create them. There are four key elements here. The good service filter and total service filter are how we specify how we're counting good and total requests. The goal is the actual objective for the SLO, the target we want to meet. And the rolling period is the time window over which we want to evaluate our SLI. Once our SLO is created, we can then create an alerting policy using SLO burn rate as the condition type. We want to be notified if our service consumes error budget at an elevated rate. In the alerting policy, we specify the threshold, the percentage of error budget consumed, and the lookback duration, the period over which that consumption can happen. If our service experiences an issue, our alerting policy will create an incident, letting us know that our error budget burn rate is too high. We then know that our service quality is degraded, and we should take immediate action to resolve the issue. Now that we have service monitoring set up and alerting for service issues configured, we can be much more confident that we'll be able to deliver on our service level objectives and keep our users happy. Thanks for joining me today. That's it for this episode. This is the Stack Doctor. Stay healthy out there.